would you like another radical equation? Very good. Would you like to pick? They are on page 185 from 11 through 30. The ones with two radicals, they're a little bit too involving, and I think that we should stick with any radical equation that you can think of with one radical. I'm ready when you are.
Number 21.
Number 21. Perfect. The square root of 3x plus 10 equals x plus 4. Perfect. My first question, I know I sound like a broken record. I apologize now for the entire semester. I will repeat and repeat and repeat and repeat. So I had a wonderful grandmother, and she would talk and talk. And we kids, I don't have siblings, but I have two cousins, and we were just, she can't stop talking. You can't just stop talking. And now I sound like her. Sorry. But it's the only way. So I'm asking myself, first of all, what type of equation is this? It is a radical equation. Then of course I'm going to ask myself, can I clean it up? Can I simplify it? And the answer is yes. How? I don't want to do that in a radical equation. If it's quadratic, I will. But for this, I can't. What did we say? If the radical has one radical, if the radical equation has one radical, what do? I'm not there yet. I have to isolate the radical first. Yes, awesome. So, or move 10 to the other side. If I don't isolate the radical, it will be a mess. Let me show you 1 second. If you square these two terms, how many terms will you get? It's on the paper on the first day of classes. How many terms would you get when we square binomial, please?
3.
Ah, and I don't get rid of the radical. The middle term will be 2 times the first times the second, and I cannot get rid of it. So that's the reason why we must isolate the radical. So I already got the answer. So it's x minus 6. That's my first step. Moving 10 to the other side, it becomes negative 10. 4 minus 10 is negative 6. Now what? Now I'm ready to do what? Now I can. The left-hand side, please. Awesome. The right-hand side. Please remember the first day of classes.
X squared minus 12x plus 36.
Do we understand this? If you say no, please look at the first document we filled out on the first day of classes. Please. So we don't fall behind and we understand and move forward. What type of equation is this now? Perfect. What do I need to do? Very good. And then I subtract negative 15x plus 36, and then? Very good. If I forget the equal symbol and 0, I'm in big trouble. I will never be able to solve. Perfect. Excellent. Now we have 4 methods. Complete the square? Of course not. Taking square roots? Impossible at this stage. I have 2 more. Factoring or quadratic formula. Which one? If it takes like this to factor, let's factor. If it takes too long, forget it. Perfect. The product is positive 36, and the sum is negative 15. I need 2 numbers that are negative because the product is positive and the sum is negative.
Negative 3, negative 12.
Very good. So there are 2 options. One is
3.
and,
12.
but look here. What does that mean? We're not certain. We have no idea. Have to go back with 3. Let's go back with 3. 3 times 3. The square root of 9.
3,
3 plus 10.
13.
3 plus 4.
7.
Done. Gone. Very good. Let's check 12. 12 times 3.
36.
30 is square root of 36. 6 plus 10.
16,
12 plus 4.
16.
Is it a yes? It is the yes, and it's the only one. Yes. So this radical equation has one solution, which is 12. Perfect. Moving on. So our next step, slightly more difficult equations. Equations with fractional exponents. With fractional exponents. Yes, we're not going to look at very sophisticated ones, just simple ones. Let's say 38 on page 185. They are not friendly equations. Not trivial, not really friendly. Okay, there is a method in the book in which it tells you do this if this, do this if that. I don't want to do that. It's too complicated. So here's what I would recommend for this. I'm looking at the equation and I see, oh, a fractional exponent. It's not polynomial, it's not absolute value, it's not quadratic, it's not linear, it's not rational. Totally different animal. So first, actually it's a radical equation to be exact. But it's not the cube root, plain cube root, right? 2 over 3 is basically the cube root of this square. So first I would like to eliminate this denominator. Like we eliminated 1/2. What do you think I have to do to both sides to eliminate the denominator of 3? Cube both sides. So let's cube both sides. The left-hand side becomes, remember we have to multiply the exponents. 2 over 3 times 3 over 1 is 2. So we have x plus 5 squared. The right-hand side is 4 times 4 times 4 is 64. Okay, not a difficult situation, basically. What is this? How many solutions do I have to get, and how do I solve it? Which method will apply here immediately? Say it again.
Taking out square.
Taking square roots. This is the second method we talked about last time. So we take the square root, and I get x plus 5 equals, if I omit something, I will make a mistake. Very good, and that is? Good. I have to separate them. It's required. So I have x equals negative 5 plus or minus 8, and I have two options. So not too bad. Now, I don't recommend the method from the book because it's longer and you have to identify this, identify that, and if this is blah, 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 blah. Don't. I can show it to you. Use it if you understand it, if you think it's better, if it's easier, that's fine. So this is the method. I don't present that. It's too long. And I don't want you to have to memorize anything. Okay, so we have negative 5, negative 8, which is negative 13, negative 5 plus 8, which is 3. Whenever we raise both sides to a power, not when we take the square root or the cube root, but when we raise to a power, we should always go back and check. However, if the power we raise both sides to it's odd, the solutions will always work. If the power we raise both sides to is even, they may or may not. So you can write that down. If we raise both sides of an equation to an even power, it's mandatory to check. If we raise both sides to an odd power, it's mandatory to check, but they will both work. Okay? That's never going to be a problem with an odd power. So you can go back, but I guarantee you both work. Do we need another type, another example, or can we move on to quadratic in form? We have quadratic in form and absolute value left. We need another example or quadratic in form. Okay, I'll let you come up next time with another example. I'm sure you will. And I'm sure and I hope you will practice between now and Thursday. Okay. Quadratic in form. What is that? Well, it means not quadratic. Not quadratic. This is not going to be a quadratic equation, but it can be replaced by a quadratic equation. And why would I do that? Only because I want to make my life easier. Otherwise, I will not. And only if it does make my life easier. Okay, so let's look at an example. Let's say 42 on page 185. And this is x to the fourth minus 13x squared plus 36 equals 0. You could say, this is not quadratic in form. This is a polynomial equation. And I will have to say you're right. It is a polynomial equation. However, I really don't know how to solve it unless it's quadratic in form. Because I don't know how to factor something like this with power 4. You can say, but I already see it, how to factor it. And then I'll say, wonderful, you are way ahead of everyone. It is possible to factor it. But I want to show you this method called substitution. Substitution. It doesn't work for all equations, but it happens to be working for this one. Which of these two, first of all, what is the degree? 4. How many solutions? 4. I make myself a note. Who knows? I may forget. I may forget to put plus or minus. Who knows? So I have to write it down. Perfect. Now, next step is, I would like you to tell me which of these two powers is smaller. I know it's a silly question. 2. I'm going to say let t, if you prefer a different letter we can use, equal x squared. So I'm replacing this by t. I know you want to ask why. In a minute you'll see why. I can do this only if this quantity is what? Without which I cannot continue. Say it again. No. But you are on the right track, I think. I cannot have x and t in the same problem. I will not be able to do anything. So if I denote exactly, if I denote this by t, this better be t squared. If it isn't, then I cannot solve, it's not quadratic in form and I cannot use the substitution to solve the equation. But now I'm asking myself, is this t squared? If t is x squared, is t squared x to the 4th? It is. Do you all see it? So that's why I will replace this by t to the 4th. I'm sorry, I meant t squared, of course. So then what is the new equation that I have to solve? Can anyone dictate?
T squared.
Perfect. This is the equation we have to solve. And you can say, but who cares about your t? And I will say, no one. The solution still has to be in x at the very end. But t is a tool that helps us solve the equation. We created it, it's our baby, and we'll go back to x in a minute. So now I see that this is in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product, yeah. I wish for a special product, I always do. What do you think? Yes?
6. All together makes 6.
Good. What is the middle term here when I expand this from the first day of classes, the form that we filled out? What will be the middle term here? Do I have that here? Good. So then, how do I factor it? This doesn't work. A special product doesn't work. Very good. Do you all agree with t minus 4, t minus 9? The product is positive 36. The sum is negative 13. Good. So now please give me two solutions in t. I want t and t. Very good. But this creates a new equation, and this creates a new equation? Can you please give me the new equation that is this?
Squared.
Exactly, because t is x squared. Awesome. X squared equals 4 and x squared equals 9. Indeed. Awesome. So I went back to my substitution. Now t is back to be x squared. Now I have a quadratic equation, which is the best method for these two. Of course, I can see it. X squared on one side and a number on the other. Quite clear. So then x equals, and if I forget something, remember this is crucial.
Plus minus 2. Plus minus.
So here are our four solutions. X equals plus or minus 3 and x equals plus or minus 2 as expected, four solutions. So this happened. We were lucky, if you want. Well, of course, all these problems are working like that is because this is quadratic in form. Don't correct anything. But if I have this, will this equation be quadratic in form? No, because if I denote this by t, this will not be t squared. So I could have not been able to solve the equation. Do we need another equation quadratic in form? Very good. Would you like to choose? Problems 41 through 57, and basically 50 to 60 actually. And then we look at the last one, which is absolute value equations. And this is my page 8. I'm ready when you are, or I will pick. Okay, 52. You have to be faster. So x to 2/5 plus x to 1/5 minus 6 equals 0. What is this? The answer is a mess. It really is. This is the what root? Fifth root of blah, blah, blah. And this is the fifth root of x, a total mess. Okay, now let's hope that this equation is in form. We hope. So if it is quadratic in form, please tell me which power is the smallest. Very good. So I will say let's say y equals x to 1/5. This will work only if what? But let's verify. So if I square this and I square this, do I get x to 2/5? Yeah, 1/5, 2/1 will be 2/5. So this is clearly quadratic in form because this one more time can be replaced by? That's it. So what is the new equation that we will be solving, which is much easier, way easier than the first one? What do I write? Yes, because remember, always, you will not make a mistake because you know you cannot have x and y in the same. Very good. So now what type of equation is this? We have four methods. Which one will work here immediately? Good. We're ready.
Y minus 2 and y plus 3.
So we got two options for y. And you can say, who cares about y? And the answer is no one. We do. It's our baby. So, good. This is a new equation. This is a new equation. Because the answer has to be given in the variable presented in the problem. We can do whatever, but the answer has to be in x. So can anyone dictate the first equation, please?
It's x to 1 and 5 equals 2. And then x 1 and 5 equals -3.
Very good. Now what type of equations are these? See how everything comes together. I know we have so many different types, and we're going to add more types throughout the semester. So what type of equation is this? It is radical. This is the fifth root. the fifth root of x, and the fifth root of x here. So both radical equations, what do we need to do to both sides when we want to eliminate power 1/5? Very good. We cannot eliminate power 1/5 with anything else but raising both sides to the fifth power. The left-hand side, please. Very good. And here x equals? That's negative 243? Okay. Good. Question mark. Why? I raised both sides to the fifth power. Well, what did we just say?
Odds are always worse.
But you still have to say, I checked. Yes, yes. Although we know that. Okay, last type. Any questions? Any questions? Yes, please.
So you always when you're like how you put 5. I don't know what I'm trying to say. Use
When
the,
I
like,
raise both-
denominator.
Because here's what. The exponential rule says copy the base, multiply the exponents.
Okay.
1/5 times 5/1 is 1.
Okay.
So it's 5/5. So that's how I get the power 1.
Okay.
Good question. Anything else? Yes, please.
What if you do substitution, but then it doesn't work out?
What do you mean?
Like if you try substituting x to the 1/5 is y, and the other one is y squared, what if you do that and you don't find a solution?
So you're saying that this one is y. This one is y, but this one is not y squared.
Yeah.
Then I cannot use this method. I have to look at the problem and see what other possibilities are.
Okay.
But yes, perfect question. If this one I say is y and this one is not y squared, the method fails. I have to find a different way. Is that clear? Very good. Good. So the last one is absolute value. I don't remember what number is this one. 5? Is it 5? Thank you. Absolute value equations. I know that you've done this before, but I'm going to start from scratch with a simple example, and then we'll pick problems from the book. So if I'm asked to find the absolute value of x equals 3, let me just tell you what this tells me. This says this to me. Find numbers called x, whose distance from 0 is exactly 3 units. 3 units, 3 units. So what are those numbers?
-3.
Is that clear? So if I plug in here 3, the absolute value is 3. If I plug in here -3, the absolute value is 3, correct? So there are two options then. And all we have to do is remember to mimic this idea throughout solving absolute value equations. Please choose anything you want, 61 through 76 on page 186. This is the last type of equation for now. For now. It's always for now, yes. Ready? Which one? 1, 2, 3? Got it. 68. So 3 times the absolute value of 2x minus 1 equals 21. Remember what we said last time about the absolute value. Can anyone refresh our memory what we said about the absolute value last time?
It is not a grouping.
Right. So you cannot distribute, you cannot take -1 to the other, you can't touch it. This is untouchable. So I'm looking at this equation and I'm asking myself, what is it? What type of equation is it?
Absolute value.
Thank you. Then the second question is, can I clean it up?
Yes.
How?
Divide by 3.
Awesome. So I have 2x minus 1 equals, in absolute value, equals?
7.
Perfect. All I have to do is mimic what we just said a few minutes ago about a simple absolute value equation. What can I have in here? What are the options for this number?
-7.
Or?
7.
That's it. So I want you to give me two equations.
2x minus 1 equals 7, 2x minus 1 equals -7.
That's it. You cannot solve this. Unsolvable, untouchable, unless You know to replace it with these two. Okay, so I add 1 and divide by 2, so I get 4. I add 1, divide by 2, and I get -3. Okay, so let's choose another absolute value equation. One more, anyone, please choose. And then I'd like to continue with inequalities. And this is the review. This is done, and we can move on to our topics for the course. Some of them may not be exactly review. They may be a little bit more sophisticated than what you've seen, but we covered everything from previous courses. In which one? 71 it is. 71. I see it. 2 times the absolute value, 4 minus 5/2 x plus 6 equals 18. Always remember, form study groups, please. I know I repeat myself constantly. And redo the problems we did in class first. We had 3 lectures, not a lot. So always go back and review those problems before you do anything else. I'm sorry about the squeaking shoes or squeaking floor. I'm sorry. If it bothers you, I apologize. Okay, so I'm looking at this equation, and I'm asking myself, what type of equation is it? Because if it's linear, I do one thing. If it's quadratic, I do something else. If it's rational, I do something else. If it's quadratic in form, I do something else. And so on and so forth. If it's polynomial, I do something else. What type is it? Perfect. Can I clean it up? First step.
Subtraction.
Awesome. So then I have 2, the absolute value of 4 minus 5/2 x equals 12. Can I further clean it up? Very good. So the absolute value of 4 minus 5/2 x equals 6. And now I'm asking myself, what can I have in here? Where my fingers are.
-6 plus 6.
Exactly. So please give me 2 equations.
4 minus 5/2 x equals -6.
Yes. Very good. So let's solve those. What type of equation is this? Yeah, well, it is a binomial, but we don't have a binomial equation per se. Say it again. We don't have radicals.
Linear.
Of course. This is a linear equation. There is no x in the denominator. There is no x squared. There is no x cubed. Linear. What do I do first? Exactly. Let's subtract 4. So -5/2 x equals -10. What do I need to get rid of now? I would like to do it in 1 step, but it's up to you. I'm fine. Do it in 2 steps. I want to eliminate this. What do I multiply both sides by to eliminate this number? That's it. The left-hand side is x, and the right-hand side is? First of all, I multiply 2 negative numbers. What is the sign? Going to be positive. I simplify 10 by 5. What do I get when I divide 10 by 5? And then multiply by 2. That's it. That's one solution. From the other one, -5/2 x equals?
2.
Good. Again, I want to get rid of -5/2 in 1 step. I'm fine if you want to use 2 steps. If you want to multiply both sides by 2 first and then divide by -5, it's fine too. What do I multiply both sides by if I want to get rid of -5? But negative. Very good. Good. So the left-hand side is x, and the right-hand side, careful, 2/1 times -2/5. I like the voice. Good. This is the end of the equations. And from the review, we only have one more thing, which is inequalities. 2 types only. Any questions for me? I know I only have 5 more minutes left, correct? Is that correct? Okay, okay. Just give me 5 minutes. So 1.7, inequalities. We are going to look at one inequality and then I'll stop. And I'm going to ask you to tell me what it is, the type. On page 203, I would like to start with a simple one because I know you want to be out of here. Let's say 40. And 45 times 3 minus x is less than or equal to 3x minus 1. Can anyone tell us what type of inequality this is? Say it again. Good idea, but it has to have 2 inequalities. That would be number 2. Very good, linear. If I had on this side less than or equal to something else, that it would have been a compound. That would be the second type. Very good. Good point. Good. So what do you recommend first? Of course. So 15 minus 5x less than or equal to 3x minus 1. Then? Yes, because both sides are completely simplified. I will move 3x and I will move 15. Can anyone tell us what I have to write next? Perfect. Perfect. Awesome. Now in interval notation, let's look at the real line. This is 0, negative infinity, infinity. I don't care for units. I'm just illustrating what this means. And 2 is somewhere here. Which direction do I go? Very good. Because of the equal symbol, I have to use a bracket. So I will say x is a number in the interval from 2 to infinity. This is the interval notation for the solution. Any questions for me?